All right, linear functions, tutorial number 1, finding the slope of a line. So we're going to interchange the words slope and rate of change. There are two different ways to say the same thing. So let's first look at this red line that we see on this XY coordinate plane. We're asked, is it linear or nonlinear? Anytime you see a graph that's just one straight line, you know it's linear. So let's go ahead and circle that. We're also asked to look at this red line and decide whether it's increasing, decreasing, or neither. And how we're going to answer this question is we're going to think about first, how do we read a graph? Because if we looked at this graph from left to right, we would say it's decreasing. But if we looked at this graph from right to left, we'd say it's increasing, right? We could argue for both answers. So we have to have an agreement. And it just happens to be that all people in the world read graphs from left to right. And one way to remember that is to think about a book. When you're reading, whether it's a book or an article, we always start from the left and we read to the right. So same thing with, now, I know in some languages we don't do that, but in our language we do read from the left to the right. So for this graph, we're going to start looking at this graph here. At the very farthest left we can see this graph, and we're going to read it going this way. So what does that mean? As we're looking at this graph from the left to the right, we see that it's going downhill, right? It is definitely heading downhill, which is decreasing. Now, sometimes people have a problem with this, and they really can't tell increasing or decreasing, excuse me. So I always say that one way you can tell is to write your name on the line. So let's say we went ahead and wrote our name. I'm going to write my name, my signature on the line. Oh, my signature is going downhill. That's decreasing. So there are two ways for you to figure out increasing or decreasing. Read it from left to right, or just sign your name on the line. All right, let's get rid of my name and let's talk about rate of change. So rate of change is the same thing as slope, and they're both referring to how much rise is there in your graph to how much it runs. So let's look at this graph. Before I can tell how much we rise and how much we run, I have to find 2 points that we can compare. And so we're going to find 2 points that we're going to call corner points. So before we find these, we're going to go ahead and remind ourselves what a corner point is. So the grid that this line is on, and any grid that we're going to look at, is made of lots of small squares. And each of these squares has 4 corners. The corner of every square on this grid is called a corner point. So there are a ton of corner points. There's a corner point, there's a corner point, right? We could just keep doing this all day, and some of us would actually find this very relaxing to do, but there are a ton of corner points, right? So what we want to be looking for is we want to be looking for the corner points that actually are on this red line. Because although these green corner points are nice, we can't use them because they're not on the red line. So let's look at the red line. I actually see a corner point. It's hard to see, but the line actually goes through that corner point and that corner point and that corner point. For some people that is super easy, and for other people, for whatever reason, they have a difficult time finding the corner point. Practice really will help in that way. So once we find the corner points, we want to know, hey, how can we get from one point to another? So I'm going to go ahead and let's look at this point and this point. I'm going to ask myself, how much do I rise? So let's see, I'm at my low point. How much do I rise? I rise up 1, 2, 3, 4. So I'm going to rise up 4 to get to the same level as my second point that I see over here, and I run 1, 2, 3. So my run is 3. But I'm not done, right? Because if I left it at 4 over 3, that means for every time I run up 4, I'm going to run 3, which sounds good, except for, wait a minute. This is a negative line, right? It's a decreasing line, so we have to remember to put our negative in front of our slope, in front of our rate of change, and we usually put the negative in front of the top number. That's really the best way to do it, especially as I think about when you answer that quiz. That's why I'm going to ask you to answer it. All right, so we're doing rate of change, which another way to say that is slope. We are step 1, finding corner points, and step 2, finding rise over run, and step 3, deciding whether we need to put a negative in front of it. And this one, I almost didn't see the line, but that red line way down there, that is one straight line, so that is linear. Now, this is the interesting thing. If we sign our name on this line, am I increasing or decreasing? Neither, right? There's no change in the way I'm writing. It's just one flat line. So this one's going to be a neither. And the rate of change is going to be interesting as well, because when I look at this and I pick 2 corner points, first of all, we got a million corner points, right? Maybe not a million, but we have a lot. So let's, we have one here, here, here. We can just keep going. And when we think about it, how much rise do I have to do to go from this corner point to this corner point? 0. I don't do any rise, okay? How much do I run? I run over 1. If you picked up your calculator and you put 0 divided by 1 and hit enter, you're going to get 0. There's no rate of change, which makes sense when you think about it. If you think about being a person and walking on this line, okay, you're walking on a line, you're like, oh, this is so much easier than the last line I was walking on. I mean, think about walking on this, how much harder it is. Give some here, right? That slope of 6 over 5 was way harder than walking on this straight line. We'll give this person a nice smiley face. Well, kind of blended in. But anyways, when the line's flat, there's no slope, and it's really easy to walk. I shouldn't say there's no slope. The slope is 0. All right, let's look at one more. Oh my gosh, imagine our person trying to walk up this line. This would be awful, right? That's a really long neck. All right, terrible to walk up this line. So think about it. Let's still think about corner points. So we're going to go ahead and use 2 corner points. And when you think about, let's rise up. All right, this is easy enough. We rise up 1. So our rise would be 1. Now, how much do we run? Well, we don't run any because we're already there. We don't have to run to the left or to the right. We're just there. So there's no running. Now, if you put in your calculator 1 divided by 0, and hit enter, what are you going to get? It'll say something like domain error, right? That's because the value 1 divided by 0 is actually, it doesn't exist. There's no value. It's an undefined value. So what we write when we see a straight up and down line, we write that the slope is undefined. And it makes sense, too, if you think about this guy trying to walk it. How do we define how you walk up? You don't. It's undefined. All right, that's as good as it gets. All right, I think that's it. That is it. Thanks for joining me. And you'll get lots of practice with finding slope of a line. And that's a real building block that's important for the rest of the high school math that you'll be doing. Thanks for joining me. See you in class.